So, welcome to yet another flip lesson during our exploration of the geometric view of trigonometry. Today we're going to talk about the area of a triangle. You, of course, know this formula from when you were in geometry. The area of a triangle is simply 1/2 the base times the height. But that formula isn't always the most useful. So we'll start out today with this problem. Suppose you live on a triangular tract of land that has side lengths of 150 yards, 80 yards, and 200 yards, just like this picture. And you need to find the area of your property. How would you go about doing that? Well, if you were just a geometry student, you would try to drop an altitude down here, and you'd have to try to figure out these angles and use some trigonometry. But it turns out that there are a couple formulas out there that might be a little bit easier to use, and we'll explore those today and see if we can figure that out. So let's take a look at one of our first formulas. So the one you learned in geometry is 1/2 the base times the height, and obviously you drop a perpendicular to one of the sides. It doesn't have to be the quote bottom side, but that would be the height in this case, and down here this would be the base. But that's not always the easiest formula out there. So let's take a look at this scenario here. We know that the sine of angle A is equal to the opposite side to the hypotenuse. So in this case, the height to C. And so I can express the height of a triangle by rearranging this a little bit and saying it's simply C times the sine of A. And if we're trying to create a brand new formula, let me go to our original geometric formula and let me make this substitution right here. So the area of a triangle is 1/2 base times height. But you see what I can make this substitution here. I can call the height C times the sine of A. And if I do that, I get 1/2 base B times C times the sine of angle A. And this is a new formula you can use to get the area of a triangle pretty quickly. Now, in this particular instance here, I want you to notice that in the formula, and I'll give you the formula, you don't have to memorize it, but you have to know how to use it. You take the two sides that flank the known angle. Notice side B and side C are flanking angle A. And that's basically how this formula is set up. Let's look at how we use it in practice. So here we go. We have this two sides of a triangle flanking an angle. In geometry, we call this a side angle side relationship. This is a perfect candidate for our new formula. So down here we have, let's see, we have our formula. Area is 1/2 B times C times the sine of A. Remember, B and C are the two sides that flank the angle. So we can just plug right into our formula. 1/2, one side 10, the other side 8, times the sine of 80. We can go into our calculator. 1/2 times 10 times 8 times the sine of 80 degrees. And lo and behold, within mere seconds, we get our area, which is about 39.39 square units. Now, did we have to have this formula? No, we didn't have to have this formula. We did some problems in class where you found the area of a triangle through a more elaborate system, but formulas are just shortcuts, and this is kind of a nice little shortcut for the area of a triangle. Let's take a look at another scenario. In this particular scenario, I don't think our new formula works very well because we don't have an angle. We have three sides. So what we need instead is a hero. And this is a little play on words. The formula we're going to use is called Heron's formula, H-E-R-O-N. However, years ago, a textbook mistyped, had a typographical error, and they called it Hero's formula, and that name kind of stuck. But it's named after a Greek mathematician, Heron. That's a little math joke there for, I guess, just for me. So let's take a look. Heron's formula involves this new idea called a semi-perimeter. And let me just spell this out. The semi-perimeter, I'm going to call it S, is half the perimeter. So remember, to find the perimeter, you just add up all the sides. So the semi-perimeter is just half the perimeter. And it turns out, through a very elaborate amount of work, and you can look this up in your book, how Heron's formula was derived, but you can find the triangle, or the area of any triangle, if you know the three sides, through this formula. It's the square root of the semi-perimeter times the difference between the semi-perimeter and each and every side. Let's take a look and see how this is used. And again, I'll remind you, I will give you these area formulas on a quiz or test. You don't have to memorize these. So if I asked you to find the area of this triangle, again, we don't need this formula. Formulas are nothing more than shortcuts. However, it's nice to have a shortcut. So if we're trying to find the area of this particular triangle right here, we could employ Heron's formula. We have all three sides. So there's Heron's formula. I guess I used P instead of S in this case, but P is the semi-perimeter. And the first thing I'm going to do is I'm going to find the semi-perimeter. So my semi-perimeter is half the perimeter. So it's half of the sum of all the sides. So the semi-perimeter is 17. And then I'm just going to plug right into Heron's formula. The semi-perimeter is 17. That goes in each one of these spots. And so we say it's the square root of 17 times the difference between the semi-perimeter in the first side, the semi-perimeter in the second side, and the semi-perimeter and the third side. And so plugging in those numbers into my calculator, I get it's about 41.23 square units. Again, both shortcuts I showed you today, both formulas, you don't have to have, but they're just nice shortcuts for finding the area of a triangle. You've already demonstrated your ability to do that. We're just trying to use some shortcuts today. Here's a summary of those three formulas. Again, I will give you these on any quiz or test, but now you see how it works. So enjoy the rest of your homework, and I'll see you tomorrow.